Okay, this is notes for square roots and real numbers. These notes were taken on Wednesday, August the 25th. And I'm going to just do a few examples. I'm not going to go over every single problem. I'll be showing the notes here on this PDF, and then I'll be writing things over to the side. So basically, when we defined the phrase square root, we talked about it being a number times itself. For example, down here for the 49, square root of 49, if you take the square root of 49, you would get 7, because 7 times 7 is 49. And likewise, that'll work with 36. The square root of 36 is 6, but since there's a negative sign on the outside, it would be negative 36. Now, some people get confused with the fractions. The square root of 25 over the square root of 81 really just needs to be broken down into two separate problems. If you have the square root of 25 over the square root of 81, you're just going to square root each separately. The square root of 25 is 5, and the square root of 81 is 9. So your answer would be 5 over 9. Moving on, let's look at some of the word problems. Word problems, we've got, let's do the second word problem. It says Nancy wants to plant Texas bluebonnets in a square plot. She has enough bluebonnet seeds to cover 19 square feet. Estimate to the nearest tenth the side of a square plot with the area of 19 square feet. So basically on this problem, you're taking the square root of 19. If we square root 19, we're going to get a decimal number, and it does say round to the nearest tenth. So if we type that into our calculator, I'll type it in mine real quick, and I'll do square root of 19. And I get the decimal 4.3588. It goes on for quite a while, but 4.35 would round to 4.4. So the estimated length of a side of the square on that one would be 4.4. All right, going down a little bit, we've moved on to absolute value. Basically, absolute value means make something positive. If you have on this problem, for example, the absolute value of negative 0.36, that's going to change to positive. So let me write that problem over here so we can look at it a little more closely. You've got a negative absolute value of negative 0.36. And when taking the absolute value of this part, it changes to positive 0.36, but because there's a negative on the outside, your answer goes back to negative. So it would be negative 0.36. And so for each of these examples, you're going to work the problem out. I'll do D. On this problem, you would multiply, after you take the absolute value of negative 25, you would multiply times negative 2. Again, this problem just requires some order of operations, and then finally multiplying times 7. D, though, let me erase this real quick. D would be worked out like this. You've got a negative, and then absolute value. You've got negative 7 and plus 23, and that's in parentheses. You're going to subtract from that 16 minus 11, and that's all in absolute value. So let's start with this part first. If we add negative 7 plus 23, since they're different signs, you're going to subtract. So that would give us 16. And then you're going to subtract from that. Right here, you've got 16 minus 11, which would be 5. And that's still an absolute value. 16 minus 5 is 11. The absolute value of 11 is just simply 11. But because there's a negative sign on the outside, your answer would be negative. So that's just some examples of how you do absolute value. And we'll have future examples of those on assignments and notes that we take. So then we got to the real number system notes. And we went through and we defined all the different number types. Basically, the number types kind of start in a progression of pretending like you were a child and then growing older and older. So for example, for natural numbers are basically the counting numbers. Natural numbers start at 1 and then go to 2 and then 3 and then on and on and on. Whole numbers start with 0 and then 1, 2, 3, and on and on and on. So basically each number set expands from the previous one. Integers are actually all the opposites also. So for example, you could have -2, -1. Going in this direction, it's going to continue out that way, meaning it would go -3, -4, -5. It's all of the negative numbers. Then, of course, 0, and then 1, and 2, and 3, and so on. So integers are all of the numbers up here, but then it also includes the negatives. Rational numbers are fractions. Any number that you can make a fraction is a rational number. For example, 1/2 is a rational number. Actually, the number 4 is also a rational number because you could make a fraction, you could put it 4/1. And then the rationals will include any of the negative numbers as well. But then all the fractions can obviously turn into decimals, so we have two different types of decimals that we can look at. We can look at terminating decimals. Terminating decimals basically stop. For example, what I had up there a minute ago, 1/2, the decimal to that is 0.5. It stops. Or if you had 3/4, the decimal for that would be 0.75. Whoops, sorry. Would be 0.75 because it stops. And then a repeating decimal is one that doesn't stop. For example, if we have the fraction 1/3, that decimal is 0.3 repeating. So it goes on and on forever and ever. 2/3 is another example of a repeating decimal, which would be like 0.6 repeating. They go on and on forever. So what do we do with all these number systems? What's their point? How do they help us understand the numbers we use a little bit better? Well, basically the number system, and I have kind of a visual example that I can give you to show you how these work. I like to think of it as a stair step. Let's look over here for just a moment. We've got all these examples of numbers down here, and we're going to classify what types of numbers they are. So we'll tell, are they real numbers? Are they rationals? Are they integers? All the different number types, we're going to classify them. So the way I like to do that is to draw a stair-step model. Here's how the stair-step model works. Basically, you've got just a set of stairs. And on the very top of our stairs, we're going to have the natural numbers. Natural numbers are our very first beginning set, so we start with those, and then we're going to go down to our next stair step, and we would have the whole numbers, followed by the integers, sorry about my handwriting on this. The next one would be your rationals. I'm going to abbreviate this one. And then we almost want to think about, let's pretend like our stairs have ended there. And then we almost want to think about our stairs ending up with two little buckets. We've got a bucket down here for terminating decimals, and we have a bucket, and let me see if I can stretch this out a little bit. We've got another bucket down here for our, I'm going to make a little bitty bucket there, and that would be for our repeating decimals. So it's almost like, let's pretend like we have a ball, and we're going to set the ball on the set of stairs, and wherever the ball bounces, that's what types of numbers you would have. For example, the first example over here is 4/9. So I'm going to take the number 4/9 and I'm going to determine what type of number it is. Well, you look at the stair steps. Would 4/9 start with naturals? No, because those are only the counting numbers, 1, 2, 3, and so on. Nor it also wouldn't start with wholes because that only includes 0 and all the naturals. It's not an integer because it's not a whole number that's negative or positive, but it is rational. So it's almost like thinking like it's a ball, and it starts right here, 4/9. And then it bounces down the stairs. Well, this is on the bottom stair, so the only other place it has to go would be in one of the buckets, either terminating or repeating. 4/9 is a repeating decimal, so therefore 4/9 is classified as a rational number. Whoops, sorry guys. Rational, and it is also a repeating decimal. If we took the number 12 right here, 12 would start up top, and it would bounce down to each step below going into the terminating spot. So 12 would be natural, whole, integer, rational, and a terminating decimal.